Good morning, ladies and gentlemen. My name is Sandeep Sovani. I'm Global Director for the Automotive Industry at ANSYS Incorporated, situated in our offices in Detroit, Michigan area. Today, I will be talking with you about maximizing engineering simulation productivity. When we talk of engineering simulation productivity, we talk of many different aspects that a company such as ANSYS can do. And I want to go through them in a step-by-step way so that you can take away some specific takeaways at the end of today's discussion. A quick introduction to ANSYS first. ANSYS is a leader in the simulation market. For 50 years, the company was founded in the 1970-1971 timeframe. Today, the company is the largest simulation company in the world, number one. More than twice as large as our nearest competitor. And it's a focused company focused on simulation. Simulation is all that we do. We're not doing CAD, for example, or CAM or things like that. We're exclusively focused on simulation. The company is fairly big now, $22 billion in market capitalization, part of the S&P 500 and the NASDAQ 100 index, with more than 87 offices globally and about 4,200 employees globally. And out of those offices, I'm in the office in the Detroit area. ANSYS' mission is about empowering our customers to design and deliver transformational products across industries, whether it's the aerospace industry, companies trying to develop components for aircrafts or new flying machines like drones and unmanned aerial vehicles, all the way from there to the automotive industry, which is an important part of ANSYS business. ANSYS is helping automotive companies develop transformational products like autonomous vehicles, electric vehicles, connected vehicles, and their components and subsystems. If you think about it, all of our customers from different industries, including the automotive industry, are facing very heightened pressures around classic challenges. Think of time to market. Having a 30% change, 30% improvement in time to market, let's say, can have a significant impact on the amount of market share that you can gain and control going forward. Or if you reduce cycle time, for complex products, cycle times, product development cycle times are in years. It takes years to develop and introduce a new product to market, and this is typical of the automotive industry. Imagine reducing cycle time down from 2 years to, say, a year and a half, and what advantage that will give to your company. And imagine the amount of new product rollouts that you're able to do. Say you're able to do a 66% increase in the number of new products that you can take out to the market. All of these things can have a significant impact on the business of a company. And simulation is something that can help you achieve that. The reason why simulation can help you achieve that is product development processes are getting complex with the digital revolution. There are many new complex things that are coming up as a part of our product development process. Chips are more and more complex than ever, which means the smart functionalities that we can embed into our systems can be highly complicated. Electronics is everywhere. There are dozens and dozens of ECUs and interconnects, etc., in a modern vehicle, including millions and millions of lines of code. That is bringing enormous amount of complexity. On the production side, we are now using more and more complex materials like composites, additive manufacturing for transforming our manufacturing processes. The Internet of Things that is emerging with technologies such as 5G would mean that every product will soon be connected to every other product. To be smart would be collecting a huge amount of data as the vehicles are rolling down the road, and they would be connected. That creates challenges, but also different monetization opportunities also if we are nimble and are able to take advantage of these new technologies that are coming out. Simulation, as I mentioned, helps in overcoming these challenges throughout the product lifecycle. So here's a chart which roughly shows you 5 stages of a product lifecycle. The first stage is ideation, where we are simply thinking of original germ ideas and playing with the ideas of a new product. Then comes the design phase, and then comes the manufacturing phase. Then comes the phase of operation of that product. And with sophisticated ECUs and computers embedded within our products now, in some cases, simulation even runs within a running product and is guiding the running of the product from within a running product. So those are the 5 stages of simulation. Simulation helps through these 5 stages of the product development process, essentially by converting data into insights. So first of all, simulation helps in accelerating your new product insertion into the market by cutting down your product development time. It helps improve your operational costs and costs out. It helps develop better products, improve the quality of your products. You can test your products in many different ways before they are released. And it helps you develop deeper customer relationships by delivering better quality products. It can also help for complex machines. It can help with predictive and prescriptive maintenance. So imagine that you are able to send an email to your vehicle customer, giving them a warning that within the next month or so, you might need to do this and this type of maintenance. You might need to get your brakes fixed, for example, or your suspension fixed, based on analysis and simulation that you're running in the background using the data that is coming off of the vehicle. And such things can help you actually generate new revenue streams that are based on data. This whole connectivity infrastructure is going to bring us an enormous amount of data. If you can simulate and analyze the data in better ways in the background, it can help you create new and better streams for monetization, apart from the traditional manufacturing and selling products based streams that we have. So ultimately, simulation helps in both enabling the top-line growth by adding such new revenue streams, getting to market faster, but also with bottom-line savings by improving the efficiency of your product development process. And simulation has become critical now throughout the industry. Simulation is actually delivering ROI to customers. And this is proven ROI and measured ROI that simulation is delivering to customers. So this is information from a Aberdeen Group study that was done a couple of years ago. And Aberdeen Group reached out to many different companies around the world, many different engineering companies around the world, and had a number of survey questions to them. One of the questions that they asked was, what percentage of your company's products currently meet your targets? And these targets are essentially launch time targets, so start of production targets, cost targets, meeting your cost, and quality targets for the product. They grouped the companies that they surveyed into 2 buckets. First are companies based on other survey questions that they identified as companies that are systematically using simulation throughout their enterprise. And then the other set of companies was companies that don't systematically use simulation across their enterprise. They might be doing pure simulation. In some cases, they might not be doing simulation. They might be doing spot simulation that is not coordinated between departments across the enterprise. So these type of companies that don't use simulation, you see them on the left-hand side column, and the companies that use simulation systematically throughout their product development process are on the right-hand side column. And systematically, they saw that companies that use simulation systematically at enterprise level, they improved on their launch targets, they had better cost targets, and they better met their quality targets, and thus being able to go faster to market, more cost effectively with higher quality products. So what is it that needs to be done? Deploy simulation systematically across the enterprise. So there are 5 tenets of what needs to be done to deploy simulation systematically across the enterprise. And I'm going to talk about each of these tenets on my 5 next slides. The first tenet is doing multiphysics and system simulation in a customized and automated way. We'll talk about all of this, so I'll just introduce these topics here and then we'll move on. So the multiphysics and system simulation is the first one. The second one is multidisciplinary design analysis and optimization. The third one is cloud-based high-performance computing and compute infrastructure. The fourth one is materials intelligence and materials data management. And the last one is simulation process and data management with an open architecture. So let's talk about each of these and see how they are crucial for maximizing your enterprise efficiency. The first one is about multiphysics and system simulation. And we will look at that from the context of an electric vehicle design process. Think of an electric vehicle's powertrain. It consists of an electric machine, consists of a battery, consists of controls, power electronics, functional safety, and all of this requires thorough system engineering to be done. So that thorough system engineering can be done with simulation. You can do simulation of the motor, the batteries individually, but also you can do a system simulation with co-simulation and reduced order models of all of these components to characterize things like the drive cycle performance of the electric vehicle, what's going to happen to the battery for a particular drive cycle, for instance, and things like that. Now, all of the systems that we deal with in modern vehicles are highly complicated. Therefore, this multiphysical simulation is essential. The multiphysics essentially means not only doing thermal analysis or structural analysis or electromagnetic analysis, but doing all of these things together. And you can see this is crucial for a thing like an electric powertrain, where a motor is a highly multiphysical object, which has structural, electromagnetic, fluid forces, all of them acting together in the motor. And this delivers real results. So you see it as an example here from one of our customers, which is Lucid Motors. They have deployed the ANSYS multiphysics simulation platform, which addresses the needs of their subsystem and component development. And they have been able to get real ROI out of it. For instance, being able to reduce the dyno calibration time by 80%, or increasing the motor's power density and energy efficiency by 12%, which is a huge increase if we think about it for an electric vehicle motor's efficiency. Next part of the tenets is multidisciplinary optimization. So we'll again look at multidisciplinary design optimization from the perspective of a electric motor in a hybrid and electric vehicle perspective. Let's look at what sort of optimization needs to be done. So take a look at the radar chart of on the right hand side. So here are different parameters of a motor that need to be optimized, and there are literally dozens of parameters. You're just seeing a few of them over here, such as mass and diameter and torque ripple and the sound and the peak torque and things like that. And here you see the requirement shown in the inner circle, and then three different designs, A, B, and C. And through doing systematic simulation with the workflow like that shown on the left-hand side, it has been possible to systematically move to better and better designs, from design A to design B to design C. Here, the simulation process goes on right at the procurement phase at the very left-hand side with materials data. Then the component development phase, a significant amount of optimization across the thermal, structural, acoustic aspects of the motor. And then the system engineering, which is engineering the motor for system integration. The third tenet is essentially about cloud computing and cloud infrastructure. What cloud computing and cloud infrastructure essentially bring to us are several aspects. Elasticity, which is giving access to adequate compute capacity as and when required. And this can improve your speed and agility of your product development process. So if you can quickly get access to compute capacity which is needed with changing business needs, like a new project that has come up or new product launch that you need to do. That improves your speed and agility. You can optimize your expenses, so you don't have to plan your compute infrastructure for peak capacity, but you can plan your compute infrastructure for average capacity and then use cloud for burst capacity. It also helps you in improving your business focus. You're not in the business of computational hardware. You're in the business of developing automotive components and developing vehicles. This using a compute infrastructure, cloud-based compute infrastructure, takes a focus away from that could be wasted in managing compute resources, and it helps you focus it on other business critical aspects. You can have a global reach with the flexibility that is afforded by the cloud. So if you're a global company, that global company can have equal access to computational resources to your engineers all around the world. So ANSYS offers a cloud computing service through Microsoft Azure, and a number of our customers have been using that for quite a while now. An example you see here is from Lear Corporation, where ANSYS Cloud reduced the solve times by 5 to 6x and cut the entire simulation workflow by half. The next tenet is about materials intelligence. There was a survey done a couple of years ago by ANSYS subsidiary named Granta, and they found out that an average engineer spends about half an hour every week simply looking for materials data. If you think of thousands of engineers around your enterprise doing that, that's quite a lot of wastage. Other thing that was found is that many of the materials tests that are done are actually not required because the data already exists. So about 20% of materials tests that are done in a company actually duplicate existing data just because that data was not accessible to the individuals who needed that data. It was also found out that material tests are often done and not reused. So 50% of all these expensive tests were used only once and never reused. So there is a lot of wastage over here. If to reduce this wastage, ANSYS provides a materials platform, materials intelligence platform from our subsidiary called Granta. This is a leading materials system for materials information and management in engineering enterprises. And just think about it. If you are able to reduce your material consumption, types of materials, you can have a significant amount of saving across the enterprise. And the last tenet is about deploying simulation at an enterprise level. So to deploy simulation at an enterprise level, across the entire product lifecycle management, you have to go through different systems, requirements, concept, preliminary design, detailed design, and then manufacturing. And for that, ANSYS provides a platform that connects with our entire simulation toolchain. This is the ANSYS Minerva platform. It has a data flow, data models, workflow, dashboards, configuration management, etc. All the tools that are needed for management of your simulation at an enterprise level across disciplines, whether it is structural, thermal, CFD, across engineering roles, across electrical engineers, mechanical engineers, all the way up to management of engineering, and for different attributes like crash test, NVH, vehicle dynamics, EMI, EMC, etc. So this tool applies across thousands of engineers across enterprise. So ANSYS offers the only true simulation platform that enables you to scale simulation across the enterprise systematically, comprising of multiphysics solvers, comprising of materials information platform, and a simulation process development platform all together in one. So in conclusion, there are 4 things to take away. How to maximize your engineering simulation productivity. First one is use smart multiphysics workflows because the products are complex and multiphysical. Secondly, use multidisciplinary design analysis and optimization, again, to optimize your products in the best possible way. Third one is use pervasive materials intelligence so that you can reduce your materials costs and improve inefficiencies in materials management. And lastly, deploy a systematic simulation process data management platform for truly scaling simulation across your enterprise in an efficient way. With that, I end my presentation. Thank you very much, and we can take questions at this point of time. So I'm seeing a few questions coming here from the audience, and I'm going to read out the questions so that you know which questions I'm answering. This one is about what are the key tenets of enterprise level deployment of simulation. So yeah, this is essentially what all I spoke about. So just to summarize that back for you, there are 5 key tenets or 5 key takeaways for you about deploying simulation at the enterprise level. The first one is about multiphysics. Our products are very complex nowadays. There are multiphysical products with electromagnetic effects through structural effects, thermal effects, all of that. So to truly optimize products, we need multiphysics optimization. That's the first multiphysics simulation. That's the first tenet. The second tenet is about multidisciplinary optimization. Your products are multidisciplinary. So products are not only mechanical products these days, but there are actuators in them, and then there is software as well. There are sensors. So there are multiple disciplines working here together. So you need to do multidisciplinary optimization of products. Choose simulation tools that are able to do that multidisciplinary products optimization. That's the second tenet. The third tenet is about cloud infrastructure. Cloud infrastructure is highly accessible these days and very affordable. So everyone should look into deploying cloud infrastructure to some extent in their enterprise, because that can help you significantly reduce your compute cost. You can actually plan your compute capacity for average capacity and then use cloud for burst capacity or peak capacity. The fourth tenet is materials intelligence. This is a hugely important topic for automotive suppliers and automotive companies. Automotive suppliers and companies can use tens of thousands of materials, hundreds of thousands of materials across the enterprise. And if you are able to reduce that by even a few percentage, the number of materials that you have to inventory and purchase, that can be a significant amount of saving for the company. And the last one is deploying a simulation process, development process. So a systematic process that can help you scale across the enterprise. So simulation, management tools and dashboards, and making simulation accessible to every engineer. There is a platform that is needed for that, and that's the fifth tenet. Next question here is digging deeper into the materials management. Okay, so why enterprise level deployment of integrated materials management and intelligence platform is required for automotive companies? So I think I touched base upon this a little bit, is that automotive companies can use tens of thousands of different types of materials. These are expensive to procure, these are expensive to maintain, and oftentimes such redundant materials are not needed. So if we have a platform, a materials intelligence platform that is deployed enterprise-wide to all engineers, then there can be standardization of materials that engineers can choose for different aspects. It also improves your materials process, where if that platform is deployed across the enterprise, you don't have to do as many materials tests, for example, or have save the time that engineers spend on simply looking for material properties. So there can be operational efficiencies like that, but the big efficiencies can come from a reduction in the amount of materials that you need to procure and inventory. That's all the time that we have for questions today. So again, thank you for the questions and the opportunity to talk with you today, and please link with me on LinkedIn, and we can have further discussions there. Thank you very much.